Okay. Welcome back again. Today we are going to finish our section. I try to cover till 1.8. So we have introduction to proof. So the important things here, you should know about some concepts. For example, we have a theorem. What do you mean by theorem? Then we have a conclusion, we have a proposition, we have a corollary, we have a lemma, we have a conjunction. We have many things here. I'm going to give you a brief history about them. Then later we are going to talk about how to understand the proof and how to understand the theorem, then how to, this understanding, this information help you to prove. So the first of all, you can see from here we have a theorem. The theorem is very important things. That's totally true. So for example, when I say 1 plus 1 is equal to 2, there is no discussion about it. We proved it before, we show that one. When we say n, for example, is greater than 0, n is greater than 0, of course, then n squared is greater than 0. When we say that, means that we prove it. We make a theorem. We state a theorem. When we say that, for example, we say x greater than 0, then, if then x squared 100% is greater than 0. So that's called theorem. Why theorem? Because 100% that one is true. If you try to solve it, you will get the tautology at the end. So that one's called theorem. Understood? There is no way to be wrong. Something less than that one is called what? It's called proposition. You can see from here a little bit less than important. When we say less than important, for example, I'm going to write here, I say, for each n belongs to z positive, let me say that, then n squared is greater than 0. So we have a theorem, it's a strong, this x is true for all real numbers, for all x belongs to real numbers, then something little important of the first one is called proposition. So that one I called theorem, that one is called proposition. Understood? Why we say that one is less important? Because we have a general case for all x in real number, that x greater than 0, then we have that one. But here, no. Small part, just only positive integers. Or you can say just natural number. So something less than the previous one is called proposition. Maybe, inshallah, during your master or during your graduation project, you have a maybe you have a theorem, maybe you have a proposition to understand what's the difference between them. Maybe during your research, you are going to search for something, you see there's a theorem for coding for something, then you have something else. Sometimes maybe you ask why we need these information. Because your specialty is 100% related to math. That's why you need the theorem, you need the logic language. Good. Again, we have what? We have a proof. Of course, you know the proof is what? Proof used for theorem. To analyze for me, to get me the point that you want to show me how that one is true in the previous one, how that one is true. To solve that one, instead of solve, because I have a theorem or proposition or whatever, you say argument or what say proposition, to show me there's no solution. In that case, we say proof. So, okay? So proof is what? I say, show that this one is equivalent with that one. So it means that show me, prove it to me, give me a clue. And of course, we have an axiom which is assumed to be true. For example, we say the first number is 1. So we have a piano theorem. Piano is called axiom. He say what? He say at the beginning we have 1, for example. So without any proving, we have 1. But for 2, he say 2 is, that one is axiom. But to show you 2 exists is called theorem, because we say 1 plus 1 equal to 2. Understood? So at the beginning, when something is totally true, and you cannot prove it, but everyone here is deal with that one. We agree with first number be 1, So that one is called axiom. Understood? You don't need to prove it to me. This is axiom between us. Okay, dears? We say, for example, we don't have a floor in the sky. We cannot stop it. Sky is not stoppable. So it means that if you are going and you have energy, you can go to up to the sky. So this is axiom. None of us went to get the end, but we know that there is no end, right? So that's why it's called axiom. Something that all agree about B exists. It's called axiom. And you don't need to prove it. There's no time, or you cannot prove it. And also we have a lemma, corollary. Corollary is, again, is a less than important, less than between is the proposition and, what do you say, a theorem. And of course also we have a conjecture. Conjecture, especially, for example, you say I'm going to write a code. I'm going to write a code for solving x to power 5. Okay, so what's a conjecture? Conjecture is your work, but you don't know at the end you will get the true or false, correct or incorrect. What do you mean by that? For example, we have a program for solving f of x is equal to x to power 5 minus 4x to power 3 plus 2x to power 2 minus 5x plus minus 2 or 3 or whatever, like minus 20. We say that one is not solvable in the exact way. We cannot solve it by any method. Let me say that one is equal to 0. Not function, let be equation. Okay, see we have this equation. Kindly solve that one for me. So your conjecture is what? I see that one solved by the student. And he needs, for example, 100 line to solve it by the coding. You say let that one be that one. We put that one. We take a limit. We write a loop, while, case. I don't know, whatever you like it. Use it. So 100 line was satisfied for solving that one. Your conjecture is what? You say I'm going to rewrite the program. Maybe I need less than the other. So it's conjecture. Maybe you are trying. Maybe you get the 15 line and you say I solve it. But when we checked, we say your solution is not good, it's not right, it's not even it's an approximate solution, but it's not accurate. So in that case, we say your method is false. But thank you, it's a great job. So you did something else, right? So we keep your job in the other part. We keep it in the library. We say do not do like that, because you'll not get the result, approximate result, accurate result. But for the other friends or the other students, we put in the do like that. At least you have that one. So this attempt to summarize or to get some result that you have it before is called conjecture. Maybe you get it, maybe you don't get it. Like a Thomas, not Thomas Carlos, the Thomas who's called find the light, right? Edison, Thomas Edison, yes. So he tried many times, right? The story is like that. I don't know the original story, but the story is like that, the famous one. He tried many times, then he get the result. So these tries means that is not workable, but a conjecture. If we put like that, we get something else. If we do like that, this is not good for the light. That's why it's called conjecture. Understood? If you get it, also called conjecture, but you got the result. That's all about the conjecture and means. Actually, it's a brief story. Do you have any question about just, for example, if I ask you, what's the difference between theorem and proposition? You know, at least you know the theorem is up, axiom is here, and the other is under. You got it, dears? Good. So now, how to understanding the theorem? We have a state of the theorem. I say, if you study hard, you will pass. We have a statement. If something, then. So how we make or how we understand the structure of the theorem. Because if you don't know how to crack the structure, you don't know how to answer. Understood? Good. So for example, if I say if x greater than y, where x and y are positive real number, then x squared greater than y squared. So how we analyze that one? How we change all these words to the previous symbols? For example, where's quantifier? Where's the condition? Where's the by condition? Do we have an and? Do we have an or? So all this word is included here. Okay, hidden. So kindly show us how we say. We say where x and y are positive real numbers. So it means that for all x and y, commas and here, either positive real number, okay, if, that's a given. If we have that was a quantifier, now we have a condition. If x greater than y, then x squared greater than y squared. You got it, dear? So means that we have what? We have a condition here. So we change the statement to understand, symbolize, or to understand, or to make the quantifier and condition symbol. Remember, understanding? Good, it's not hard, just analyze it. So here we are. Then, if you understand how's the statement, how to analyze the statement, of course, you are ready to solve. So how we solve? We have a method. Sorry, we don't have a solve. We have what? Proof. How we prove? We have a method. We have a direct method and indirect. So today I'm going just cover direct for you. Okay, good. Now we have a proof. Look at your Kakijan. Two branches, direct, of course indirect, right? Indirect. The direct method is like that. P then Q, without negotiation, just straight, P then Q. I'm going to start the P, you give me the information. Encourage you to say draw. We have information, we have the given, then we are going to use our information the before, our conjunction, then and that one, then directly we get what? Dawa crow, result. So we prove it. You got it? So it's called direct, without any change, negation, anything, just direct. Okay. Also we have indirect, but indirect we have two-way, another method. Okay, how? Let me say two subway. We have a two-way, two method, two sub-method. It's called contraposition and contrapositive. You heard about the contrapositive, and today you have contraposition or positive and contradiction. So contradiction and contraposition. So we have two contra, which help us to solve indirect. Okay? Understood, Kakijan? To solve indirect. Good. So now today we are going to cover that one because you have some assessment, like a quiz. Then next lecture, we try to cover the rest. Clear? So direct is very important. How you solve direct? This is the name. Okay. This is the statement or proposition. And now here's the definition. We don't need this definition does not relate to the proof. Help you to something else. And here's the first example. He say with the example, he say if, forget about this definition, later I'm coming back to them. If n is odd integer, then n squared is odd. So how we understand that one, how we analyze the statement, that's the first requirement. Second, how we solve, which method we should follow it, which method we should apply it. Understood? So n is odd, then n squared is also odd. And n is what? Look at the example kindly. Odd integer. So how I change that one? I say for all n in integer number, right? It's a quantifier, means that one is 100% true. If you have a one counter example, give it to me. We haven't. So for all integer n, okay, n is odd, then n squared is odd. Now I analyze that statement. Understood? The second step is what? First, analyzing the statement. Second, prove the statement. When you analyze, when you understand it, when you change it to something else. So, before we are going to solve or prove this theorem, we need a definition of odd and even number. What do you mean by odd number? What do you mean by even number? Okay, dears? Yalla, tell me. We say that you can if you forget about it, you can review this definition. So I'm going to give you yalla. What's the odd number? Yes.
What is a number that if you square it by rejecting lunch, what number do you have?
No. Definition odd number. You are right. What's your makabu both kida makuri? Thank you. Yes.
A number that is not divisible by 2.
That's the first. Another one.
Yeah.
The same. So in Cal 2, chapter 10, Tyler. Do you remember when we make a formula for Tyler? So we have what? We say n is odd. Then look, there exists k in z. We have a k in z, such that how n can be written as this formula. Am I right? Do you remember that now? We use that one. If you don't remember, I don't care. The important thing is, you know, that was the formula of odd number, right? Good. So tell me about even number. N is even. There exists maybe k, l, anything, k in z, such that how n is equal to 2k. Okay, 2k. Am I right? So whenever you saw that one, you know, we mean by odd number. I mean that one. Whenever you saw that one, you know n is even number. Do you agree with me? Any comment?
Plus minus.
Yes, but here we are going to use plus because we make a k to be anything. You are right. Sometimes you use the minus. Okay. Let me rewrite or reread the announcement. Announcement again. Do not be late. Do not be sick. Do not be absent. Do not put your mobile like that and put it upside down. Then, of course, make it a silent. Good. Understood, Kaka? Good. Also instruction, reclam. Good. Now, and we'll record that reclam, you know, to remember every age, every stage, remember. Okay, now, yalla, going back to the statement. If n is odd, then n squared is odd. We know for all n belong to integer number. Now, I say p, then q. We change to our, and of course, the first theorem needs more time. The second and the third, you will deal with it. So because n is odd, so n is odd, n squared is odd. Am I right? That's the PQ. So to prove that one, first we are going to use the direct method. We are going to start with P to get the Q. So n, we start with, because directed, we are going to start with n. Why n is odd? Because this is P, n is odd. Since by given, so let me write like you, because I know you're like an order, I know. So let me write like you. There's the answer, proof. We are using direct method to prove. Okay, to prove. So since by given P, n is odd, right? So n equal to 2k plus 1 for each k. Now there exists k in integer number, right? Yeah, we can find the k in integer number to show me that one. Do you have any problem? So that one's given. Understood? Hello? Good. Now, we are going to solve, to prove. So n squared is equal to what? Am I right? Some book is written like that. Some book is written like that. Means that's the next step. Next step. Okay? So I'm going to use that one, for example. So let me remember you something. Let me give you something. We want to show that. We want to show n squared is even. That's your duty. So now we say n is even. Now n squared is equal to what? 2k plus 1 square. Am I right? Yalla. N squared equal to what? Yalla.
4k squared.
Good. Then what else? Yalla. Next step.
We will take 1k. 2
Why 2? You are right. Thank you. So n squared equal to 2 kawana. Okay? K
plus 2 and
plus 1. Why? Why he did like that? Yes?
we can just take 4k.
No. 4k?
Next to the old formula. Turns it back into the old formula.
Yeah, to get the odd formula, right?
With the n to
Why? Shall I, if I repeat, write something like that? Do you agree with me? Do you agree with that statement? With this step? Huh? I change it to L. You can change it to M. Whatever you like. K.
Yeah, you can do.
We can. Why? So what's K? What's L? Sorry. L is equal to what? 2K. That's okay. I have another question. Thank you. Answered everyone correctly. So, tell me about this. L is integer or not?
It's variables.
A variable, that's integer number or not? Yes. Why? Because I have k is an integer. 2 multiply k. Okay. Plus 2k squared again. Integer plus integer. So I can write down like that. There exists L belong to integer, right? L also is belong to integer. So I wrote n squared as a 2 integer plus 1. Means what? Huh? Which means n squared is odd. You prove it, right? It's like a game, like a puzzle. Kindly make your mobile things silent. Okay. So means n squared is odd. Understood? Tamam? So you know how to use the direct. You don't need to make it more mess. That's a direct method. He say we can use that one, use that one. Here's anything that you give it. Now, second example. Second example. He say what? Give a direct. That time he's specific. The question is what, Kakijan? The question, the theorem is given what? Give a direct proof. So means that maybe you can prove my question, my example by indirect also. Maybe by contrapositive or contradiction later. So during the exam or quiz, if I don't say anything, you are free. But your steps should be logic. Careful. Otherwise, when we specify the question, we say direct proof, you need to follow the direct proof. Clear, dears? Good. Now, we have direct proof to what? To, yalla, tell me about that one. Analyze this statement, kindly. Can you analyze this statement? Can you analyze this statement? Hello? Yalla. Think about it. You need maybe 1 minute. It's okay. Think about it. $45. 30. 15. Yalla. Time over. Yalla.
It's saying if m and n
Hmm?
are perfect square,
Hmm? Hmm?
if you combine them together, m and n are still perfect square.
Good.
Also, if a is also perfect square, then do you think that b square can be perfect square too?
No. The first part was good. The second, you make a mess. Wait. What else? Yalla.
Second part is the definition of a perfect square.
The second part is the definition of perfect square. How about you? The same.
But it says A
How about the statement of the theorem? That one's definition. Forget about that one. You know, that's not the statement of the theorem. That one's the statement. So give me the analyze of the statement.
It says if we have m and n,
Uh-huh.
they are both perfect squares.
Perfect square.
Then together they
Together.
are also a perfect square.
So-
And
So-
n was equal to x squared.
Thank you. That's what I want to say. So n equal to something squared. We call, for example, a. Okay, a squared.
Also m is
At the same time,
b squared.
m at the same time, and m also is perfect square, right? So show what? We want to show what? We want to show. That's why I make a long to understand. We want to show what? Mn equal to c squared. Am I right? That's what we need. As they mentioned, and she said, and when they said. So the given. Let me change that statement. I say m is equal to a squared or b squared does not make a sense, and n equal to, maybe I change it here, no worries. Did you like that? Okay. The same. B squared, then mn to c squared. That's what I want to say. So that's the given P. That one requires theorem Q. Clear, right? It's not hard, just understand. So how we get that one? Direct. And he say use direct. There's no way to change the negative. So I say by given, for example, proof since by given a m equal to a square and at the same time n equal to b square, then mn equal to what? No.
Equals to a.
That's why I changed the words to understand. A. Then what's next?
It's a and b, so it will be a.
Easier. You are right. Let's make it easier. No.
So ab squared. AB
That's what I want. Thank you. Working at least. That's what. Yeah. So now, can I write that one? Hello? So we get the result. Don't say, well, I know that one is equal to no. Right, because that's a step and we need. Understood? Dears, clear? That's one, what you want to show during the exam. You should write every single step with a reason. For example, because. If you can't, at least show me your step. So here's the proof by direction or direct method. Now we have contraposition and what? Contradiction. We say that we have a proof, direct. It was P then Q without any sub method. Now we have indirect, then contraposition or contrapositive. So how we solve by contraposition? Just I'm give you the style. We have P then Q, right? of course, our theorem. So we change it to what? Negation Q, then negation P. So we are saying let that one not be odd, then you will get that one is not odd, like that. We don't have an exam, we are not going to study. So if you have an exam, you should study, right? So I'm not studying because I don't have an exam, like that. So I'm going to solve it later. For today, do you have a question? Do you know what's the meaning of make your mobile silent? Do you understand how to analyze this statement? Means that bring your mobile. There's a button in it, say silent or airplane mode, and like that. So kindly do it. It's not hard. So today we have what? It was discrete, and that's all. Okay. Kaka Galina, sorry, record the button.